All right, now, so before we, so we're going to continue now with our discussion about lists. Specifically, though, we need to talk about generics. Now, fortunately, we don't really need to know too much about lists in order to work with them. That was last video. So in here, I'm going to just talk about a few more things we can do with lists. Or rather, I'm going to narrow in on two method calls that we can do with lists. The first is list.add, right, which we've gone over pretty extensively at this point. We are basically given an item. We just add it to the list, and it gets tacked on to the end of the list. So I add 100, and then I add 50, right? Then the list becomes 100, and then it becomes 50, assuming I can, type properly and all that stuff. Right? We get list here. See? Can't type properly. Okay. So now run this. 150, right? First, so we add 100 to the list, then we add 50 to the list, so the list is 100, and then it is 50. Straightforward. And then if I want to get something at a specific index, like, I can just get, ask it to get the index. That's the method call. So, list.get 0. That'll get index 0, right, which is 100. Get index 1, let it rebuild, get index, and then we get 50. Okay, that's pretty good so far. Okay, now, of course, if I go for like index 5 or something, that index doesn't exist, so I'm going to get an error. I'm going to get an index out of bounds exception. 5 is out of bounds for something of length 2. Makes sense. Okay, so now, this is great. This seems pretty straightforward, right? Don't really need to know much more than this. But I keep getting these warnings about unchecked called to E as a member of the raw. So basically, this is saying so basically what we've done is that we've created a list. And you can add anything to a list. Right now I've been adding, integers here, but there's nothing from stopping me from adding a string to this list, right? Now I'm going to print out the entire list, right? Nothing stops me from adding a string. 150, hello. Okay, and that's pretty cool. You can make something something that holds anything and everything, right? You can just collect all different types of data in here, and that's great if that's what you need. But most of the time, you don't need that. Most of the time, when you create a list, it's a specific list of stuff. You want a specific list of integers and a specific list of, specific list of strings, right? We don't want a list that often we don't want a list that holds anything. We just want a list that holds one type. Okay? So that's so that's where generics come in, and that's one reason for the generics. The other reason for generics is just safety, right? And which I'll demonstrate now. Suppose that I'm creating a list here. Sorry. So suppose though that safety and convenience. All right? So let's go ahead and just create a list, right? Suppose we're just taking in numbers, right? And we're reading numbers from a file, okay? And I'll just put some numbers here, though, to demonstrate, right? And suppose we wanted to sum up all those numbers, right? This is a pretty good use case for lists, right? A lot of times if a file has numbers, you don't know how many numbers are in it, so you'll want to read a number and then add it to the list. Makes sense. Okay? So suppose we wanted to print the sum of all the numbers in the list. Okay? So let's go ahead and create a loop that does that, right? Just like we would do it with an array. Int sum is equal to 0. For int I is equal to 0, because we're going to start at index 0. We're going to go through indices 1 through 3 in this list, right? So indices 0 to n minus 1, where n is the length of the list. List.size, I++, right? All right, and now we want to get the value int. This is an int, right? We're storing an int in the list, so we're going to say int value is equal to, and I could easily do this in 2 lines, in 1 line, but I'm breaking it up into 2 just to show. Int value is equal to list dot get the ith item. It gives me an error, and I'm just going to ignore it for right now, but you should never do that. But I'm ignoring it for pedagogical purposes. And now sum is equal to, and so we get that value out of the list, and we say sum plus equals that value, right? Okay, but we got this error. What's going on here? It says incompatible types. This is an integer on the right, where we're expecting an integer, and what it says is that you've got objects here, right? This is a list that holds anything, right? So, remember, everything in Java is an object, right? So a list that holds anything is really a list of objects. Okay? Makes sense? Since everything is an object, although that kind of breaks down a bit, right? Because these are primitives. We'll get to that in a second, right? But everything in Java is an object. So if we're adding a bunch of ints to this, or rather integers to be correct, if we're adding a bunch of integers to this, then, those are objects, so they can be added to my list of that basically holds objects. So the state of before Java 4, before Java 5 was this, which was that basically you didn't have generics. And as a result, whenever you basically had a list of stuff and you knew there were just integers in there, you got into a bit of a hassle, where basically you had to cast things. You had to tell Java, no, it's a list of integers, trust me. It's a list of ints, trust me, okay? And so you have to cast them, right? Do this to tell Java, trust me, this variable's an integer, okay? So now you run it, and 156. Right? That's our sum. Okay. So that's a small frustration there, right? And when we use generics, we won't have to cast things, as you'll see. But that leads ourselves into a possible way of shooting ourselves in the foot, right? I could be adding a whole lot of stuff here, right? Like I could have a couple thousand lines of code right over here. Code, right? More code, right? And then like 100 lines later, I could accidentally forget what's in there and accidentally add, some string in. Right? So this is a risk. You run this risk when you don't have generics. And now if I run this, right, there was no errors here, but we'll iterate through, we'll add everything, 155, 1, and then we're going to try to add hello. Specifically, we're going to get hello out, and then we're going to cast it to an integer. So in other words, we're going to try to turn this string into an integer. That's not going to work, right? And that's where we get an error. Java string cannot be turned into an integer. Note that it says integer as opposed to int. Again, we're going to get to that. All right. So that's a bit of a issue there. So with generics, we can get around that. Okay? So this is why we use... So this is the reason that generics exist. To prevent ourselves from hurting ourselves accidentally, and to make it easier to do stuff. So first I'm going to demonstrate with a list of strings just to make it interesting. Just to make it straightforward, and then we'll move on to how you handle ints, or specifically integers. So notice over here when I started typing L and there's list, it has this less than, E, greater than. This means this takes a generic type. So what we do here is to declare a list of strings. We put our less than sign, and then we type string in there, and then we type greater string. And this reads as a list of strings, right? So list of strings list is equal to a new list array list. Now we can put string here depending on what IDE you use. I think it depends on what you put there. I like to do this because it's explicit, although NetBeans is perfectly happy with this, just to say it's a new array list. But I like to do this because it's because it is symmetrical. So a list of string, this is a new array list of strings, right? An array, that's how you read this. It is an array list of strings. This is a list of strings. Okay, so now as a result, when I do list.add, notice that the type over here is string, right? What was it before? What was it before this? if I don't have this string over here, okay, if I don't have this string indicator over here, when I do list.add, it's object, because we don't know what we're adding, but everything's an object, so we can add an object. So so here we're saying it's a list of string. We're not adding any object. We're adding string. And notice the other add method, the one that takes an index. The second argument has changed into a string. And the way this works is and we're going to get into this as we write this, is that there's basically, oh yeah, we'll get into this in a bit. I'll write something with the generic in just a bit. Is that there's essentially a field that has an E in it. And then once you declare what that generic type E is, it goes and replaces all of those instances of the generic with string in it. So it replaces all the instances of the code with string, effectively. Of E with string. So here, add hello. If I put in hello, list.add dot add world. Awesome. List.add hi. Sout. And now, when we go through, if I were to create a list to go through this, for int I is equal to 0, I is less than list dot size, I plus plus, sout list dot get I, right? Or alternatively, so that works. Or alternatively, since we know this is a list of strings, right, I can do a for each loop. For each string word in our list, sout word, which looks a lot more concise. And once you are used to reading this, it's a lot more readable. For every word in the list, and we know it's that everything in the list is a string, so we put string here, right? We print out that word. All right. So next video we're going to discuss how these generics actually are made.